Before we go into this lesson, you need to be totally okay with the idea of what equivalent fractions are and how you find them. Also, you must be good at adding and subtracting fractions when the denominators are the same. So when the bottom number in the fractions are the same. Right, don't ever fall for this trap. Some people, when they're adding fractions, think that you just add the numerators, so in this case 1 add 2 is 3, and then you add the denominators. 4 add 4 is 8. A quarter add 2 quarters is not 3/8. That's totally incorrect. If you've seen the video about adding and subtracting fractions where the denominators are the same as they are here, you'll know that you only add or subtract the numerators. The denominators stay the same. So in this case, 1 quarter add 2 quarter, we do 1 add 2 is 3 for the numerator, but the denominator stays as a quarter, stays as 4. So a quarter plus 2 quarters is 3 quarters. Just a quick recap about equivalent fractions. Here I've written that 1 quarter is equal to 3/12. They're equivalent fractions. That means they're exactly the same size. They're describing the same number. They're describing the same proportion. They're exactly the same size as each other. Remember how we find equivalent fractions? We basically multiply the numerator and the denominator by the same number. That can be any whole number. In this case I've chosen 3. So 1 times 3 is 3 for the numerator, 4 times 3 is 12 for the denominator. So 1 quarter is equal to 3/12. If you don't really see how equivalent fractions are the same size as each other, here's a really good way to think about it. Fractions are really just division sums. So a quarter is exactly the same thing as 1 divided by 4, which is 0.25. 3/12 is exactly the same thing as 3 divided by 12, which if you type that into a calculator you'll find comes out as 0.25 as well. So 1 quarter and 3/12 are equivalent fractions. They are describing the same size number, which is 0.25. Okay, what I'm going to do is start with a fraction sum where the denominators are the same. So in this case, 1 quarter add 2 quarters is 3 quarters. What I've done in the top left example here is I've changed that 1 quarter into an equivalent fraction 2/8. Now 1 quarter and 2/8 are equivalent fractions. They're describing exactly the same size number. So if 1 quarter add 2 quarters is 3 quarters, 2/8 add 2 quarters must also equal 3 quarters. They must get the same answer because 1 quarter and 2/8 are exactly the same size number. They're equivalent fractions. Okay, in this top right example, what I've done is I've just used a different equivalent fraction for 1 quarter. So if 1 quarter add 2 quarters is 3 quarters, I can also say 3/12 add 2 quarters is 3 quarters. Because 1 quarter and 3/12 are exactly the same size, they are equivalent fractions. In this bottom left example, I've just used an equivalent fraction for 2 quarters. I've changed that into 1/2. They're equivalent fractions, so they're the same size. So if 1 quarter add 2 quarters is 3 quarters, 1 quarter add a half must also be equal to 3 quarters. To finish off here on the bottom right hand side, I've actually used equivalent fractions for both of them. So I've changed 1 quarter into 2/8 and I've changed 2 quarters into its equivalent fraction 6/12. If 1 quarter add 2 quarters is 3 quarters, then because they are equivalent fractions, because they're describing the same size number, 2/8 add 6/12 must also be equal to 3 quarters. The idea that I'm trying to get across here is that the fact that you change the fractions, so long as they are equivalent fractions, it doesn't change the answer. The idea is that equivalent fractions are describing things that are the same size. And so if you change a fraction into an equivalent fraction, the answer to the sum doesn't actually change. That's the main idea that I've tried to get across here. Okay, quite often, or what we've done here, we've taken a fraction sum where the denominators are the same, and we've changed one of those fractions using an equivalent fraction to come up with a fraction sum where the denominators are different. So a quarter add a half. Denominators are 4 and 2, they're different. Quite often what you end up doing is actually going the other way. You get given a fraction sum where the denominators are different, and you use equivalent fractions to create a fraction sum where the denominators are the same. So in this case, we'd start with the bottom left example, and we'd move to the example above it. We'd change the 1/2 into 2 quarters so that we've got a fraction sum where the denominators are the same. That's a really good thing to do, because once the denominators are the same, it's really easy to add those two fractions together. So long as you remember that you just add the numerators, that's easy. Okay, so let's have a look at how this actually works in real life with a couple of examples. We're going to do 1/3 and 3/6. So what I want to do is rewrite that fraction sum by using equivalent fractions to make the denominators, the bottom numbers, the same. So what I'm going to do is I'm going to change that 1/3 into 2/6. 1/3 and 2/6 are equivalent fractions, they're the same size as each other, so if the top fraction sum must be equal to the bottom one. Okay, now I've got the denominators the same, they're sixths. I just add the numerators. 2 add 3 is 5, leave the denominator as 6. So if 2/6 add 3/6 is 5/6, we know that our starting question, 1/3 add 3/6, is 5/6. Why do we know that? Because that 1/3 and 2/6 were equivalent fractions. Okay, a look at how subtraction 1 works now. 7/8 take away 2 quarters. What I've done here is I'm trying to work towards rewriting the fraction sum where the denominators are the same. So what I've done is I've found an equivalent fraction to 2 quarters, which is 4/8. And now that I've got that far, I've rewritten the fraction sum, and you can see that the denominators are now the same. I used an equivalent fraction to do that, to change 2 quarters to 4/8, but now that the denominators are the same, it's really easy to do the sum. We just do subtract the numerators, so 7 take 4 is 3, and leave the denominator the same. That's 3/8. So 7/8 subtract 2 quarters is 3/8. Sometimes it's not always easy to spot which equivalent fractions to use to make the denominators the same. It was easy in the last couple of examples because one denominator was a multiple of the other. But in this case, it's not particularly easy to see what I should change 2/3 into and what I should change 1/5 into to make the denominators the same. So I'm going to show you a nice little method that you can use that will help you out with this. So the first thing to do is to take both of those fractions and put them in a little star or a circle, as you can see here. The next step is for each of those equivalent fractions, for each of those fractions to draw around it equivalent fractions to itself. So 2/3 I've written 4/6, 6/9, 8/12, 10/15, and 12/18. These are all equivalent fractions to 2/3. So I've written them around that fraction. On the right hand side, you can see that I've written equivalent fractions to 1/5. So 1/5 is equal to 2/10, 3/15, 4/20, 5/25, and 6/30. Okay, so you take the two original fractions and then around them you write equivalent fractions to them. The next thing you do is you have to spot which of the equivalent fractions in each side have the same denominator. So in this case, 10/15 and 3/15 have the same denominator, 15. So you use these two equivalent fractions to rewrite your original sum. So I take the 10/15 and I add to that 3/15. So just to recap, this has been a little method that we've used to spot which equivalent fractions we use to turn 2/3 add 1/5 into 10/15 add 3/15. Okay, once we've got that far, it's nice and easy. We just add the numerators. 10 add 3 is 13, leave the denominator as it is. So the answer to our original question is 13/15. So just to conclude what we've learnt in this lesson, I'm going to do one more example where I explain the process one more time. If we've got 3/4 subtract 1/5, the first thing that you have to do is use equivalent fractions to rewrite the calculation with fractions that have the same denominator. So in this case, I would use 15/20 as an equivalent fraction to 3/4. I would use 4/20 as an equivalent fraction to 1/5. Why have I done that? Because I want to rewrite the calculation with fractions that have the same denominator. Next up, when you get that far, you either add or subtract. Subtract in this case the numerators, and then the denominator stays the same. So 15/20 minus 4/20. 15 take 4, for the numerator is 11, the denominator stays the same. So the answer to this one would be 11/20.